Hello and welcome to another Solana tutorial. Today we're gonna talk about the x402 standard. Cause I asked you guys on X what topics you want me to make more content about. And this was by far the one with the biggest response. And I didn't even know what it was. So I spent the last 2 hours researching it. And now I'm like, well, that's actually a really interesting topic. And I want to make a video about it. In fact, it's such a big topic, I might make more videos about that. And in this first part, we're just gonna talk about what it is, why it's useful, and how it can be used. And then we're gonna do more technical deep dives in future videos. How does that sound? Sounds good to me. That's all it needs. Let's get started talking about x402, which is a protocol for micropayments. Technically not even necessarily micropayments, but most likely to be used for micropayments. x402, an open protocol for internet native payments. There we go. Internet native payments. The best way to accept digital payments. Built around the HTTP 402 status code, x402 enables users to pay for resources via API without registration, emails, or complex signatures. So that's supposed to simplify online payment. Has no fees, is blockchain agnostic, so doesn't matter which chain or token. It's an open standard, there's instant settlement, it's frictionless, and it's web native through the 402 HTTP status code. That's where it got its name from. By the way, if you don't know this, the HTTP status codes, HTTP is the protocol we use for web pages, the hypertext transfer protocol. You've probably seen the 200 OK. So when a page comes back with 200, that means everything's fine. So you've probably seen the 404 error. Maybe you've seen a few other ones. The 400 ones, those are the ones where the server says, client, this is your issue. You requested something that doesn't exist. The 500, those are the server errors. Oh, there's something wrong at the server. 500, internal server error, for instance, or not implemented or whatever, or service unavailable. But the 400, those are the ones where the server says, client, you did something wrong. And in the case of 402, there is a payment required to access this page. 401 is unauthorized, 403 is forbidden, you can't access that. But the 402 is payment required, a non-standard response status code reserved for future use. This status code was created to enable digital cash or micropayment systems and would indicate that the requested content is not available until the client makes a payment. No standard use convention exists and different systems use it in different contexts. So this was put in the HTTP protocol years ago, decades ago, when there were no micropayment systems. But they put it there anyway, just in case that ever exists. And guess what? Now that exists. And one of them is the x402 standard that uses blockchain to perform those micropayments or general payments. So yeah, the promise here is that with a single line of code in your app, you can require USDC payments on incoming requests. And if there's a request received without the payment, we get the 402 response code. That's a high-level overview. So we're using this such that a website can tell the client, hey, I require a payment for this, and then the client can do the payment, and if that's done, then the website will serve whatever it has to offer. So you can use that for paying for content, or what is probably mostly used for nowadays will be for AI agents to pay for certain services. And in order for them to be able to do that, there needs to be some kind of standard that is easy for them to do that, such that they can do it automatically, right? Without requiring a credit card or whatever other payment forms there are on the internet. With this, it's gonna be fairly simple to make quick, small payments. So how does it work? There are some docs somewhere. Read the docs, here we go. Oh, that's bright again. x402, the open payment standard. With x402, any web service can require payment before serving a response, using crypto-native payment for speed, privacy, and efficiency. Yay! Crypto-native. So why would we use this? Because there are no high fees. It's compatible for machine-to-machine payments. That's what makes it so attractive for AI agents. It doesn't involve any humans anymore. And we can do micropayments, so really small payments. And that's also why Solana will be helpful here. We need a blockchain that supports really cheap transactions with fast settlement. So who is this for? Sellers, those are the service providers who want to monetize some kind of API or content. So every time you do an API request, you have to do a micropayment. Or anytime you want to retrieve the content, you'll need to do a micropayment. And on the other side, the buyers, so either the humans or the AI agents, who want to access paid services without having to go through manual flows or creating accounts and whatever. This standard will make it much simpler because it's built on top of HTTP. And that's a protocol that is widely used. So what can you build? APIs that you pay per request, paywalls for digital content. How does it work? At a high level, the flow is simple. I saw a better graph for this. Where did I see this? GitHub, maybe it was here. Yeah, that's what I wanted to see. Okay, here it is. So we have 4 entities here. Usually with a classic website, you have the client and the server, and the client requests something and the server serves it, right? Without the micropayment stuff, that's what we have. We do a GET request and we respond ideally with a 200. This is the web page. Cool. But now we add 2 more entities. We have the facilitator who is responsible for handling the actual payment stuff on behalf of the server, and then the blockchain, which is the persistence layer of the actual payment, like where the actual payment happens. So the client, which could be you as the user or an AI agent, will make a GET request to the server with HTTP as they would in any other case, but then the server responds with HTTP 402 payment required. And in that step, it will tell the client what exactly it expects as payment. So which blockchain, which token, and how much. And then the client will basically create a transaction, which is then included in the header doing another request to the server. The server then forwards this to the facilitator who does the actual handling of the payment, because the server itself doesn't want to bother with interacting with a blockchain or doing any kind of verification. That's all done by the facilitator, because the server really just wants to run their API or host their content, and all the payment stuff, it's the facilitator's job. So the server will tell the facilitator, hey, I got this request from my client, can you take care of that? And then the facilitator will say, yeah, that sounds valid. The server might now still need to do something, and then comes the settle step. So the verify step is just, is that a valid transaction that they sent me, or a valid payment method or whatever? And then the settle will actually execute, so please make it happen, the payment. At which point the facilitator will then actually interact with the blockchain and send that transaction and wait for the confirmation. And once it's settled, it returns to the server success, yes or no. And if there was success, then the client will get the actual response from the server, because the server now knows once it's settled, okay, the payment has been done. So we can serve the client with the actual response of whatever the API does or whatever the content is. That's the flow. Some notes. There's latency introduced. Yes, because we do need to confirm the transactions. Server can opt to not await settled response from the facilitator to having faster API response times. So once the server called settled, it doesn't need to wait until it got the confirmation that it's actually settled. It could already here start serving the request to the client, because it knows from the verify that that should work. But if the blockchain is fast, then hopefully we can await this without much concern for user experience or AI agent experience. Yeah, so that's the flowchart, the high level overview. I do want to get a little bit more into detail though how that works for Solana, because originally this was developed by Coinbase, right? Coinbase brought that standard, but they have specs for the Solana virtual machine as well. That was added in this commit. Add support for Solana. And it's based on this diagram. There we go. So we again have client, server, facilitator, and the Solana blockchain. And it's similar, but we need a few more things. So when we do the GET request to the server, with the 402 payment required, we do add an extra account, a pub key, for the fee payer, because that standard allows you to pay in any token, but Solana also requires transaction fees. And if the client needs to build the transaction, then it needs to know what the fee payer is. So that's what we put into this extra. And then the client fetches a block hash from the blockchain directly, because that's simple enough, and then builds the transaction and partially signs it. Then it base 64 encodes that, puts that in the X payment header of the request to the server, and then same thing happens here as well. The server will call the verify to the facilitator. Facilitator can then simulate and send transaction. Maybe the verify only does verify. Here it looks like the verify also already sends the transaction, but maybe that's a different step in the settle. But anyway, the facilitator will then actually send the transaction as well to the blockchain and confirm with the transaction signature, and then the server can serve the request, which is a regular HTTP 200 with the following header, the X payment response, that will contain the signature as well in the header, in case the client wants to do anything with that signature. Confirm it for themselves or put it in their archive, whatever it is. That's how it works for Solana. So just a simple add-on with this fee payer. Yeah, they added a fee payer endpoint to the facilitator. So the facilitator can return different fee payer addresses. Yeah, we can dig into the details in a future video where we really analyze that. For now, I would just like to try this out somehow. I want to see it in action. And there's this try out, but that's for base. I want to do that for Solana. Let's see what we find. Solana example. There's a Rust-based implementation for this as well. Oh, but that also looks very not Solana. How about this? Guy which uses the 402x standard with Solana to get responses. Let's try this. Clone it. I mean, I have no idea who that guy is. I have no idea who is Pratik. But it doesn't matter. I'm not using real money here anyway. It's just for demo. So git clone. Cloned it. 402 Solana UI. Actually, let's open it and see what we have here. The app. Oh, that looks like a Next.js or whatever app. Then we have middleware. It uses the kit and next server. Yes. Cool. Yeah, let's install dependencies and then just run dev. npm dev. Compiled middleware. And well, let's just go to localhost and see what's there. We're getting errors. But get, see, 200. So what we got, right, is this nice little thingy thing. Welcome to Solana AI Chat, your AI assistant powered by Solana Payment. Each message costs 1 cent. Ask me anything, let's have fun. So if I ask anything, I probably need to pay. And for that I need to connect a wallet. And for that I need a wallet. Oh, Brave has a wallet. I must use Solana and Ethereum. I can't even unselect them. Great. Okay, yes, fine. I don't know how I can get to DevNet though. Maybe I will use a wallet that I know. Because here at least I know how to go to DevNet. And then, oh wait, maybe I don't even need a wallet if I generate a wallet here. Generate key pair. Great, I've got a key pair with 0 USDC. How can I get DevNet USDC? What's the mint of DevNet.sol? USDC DevNet mint. This. USDCfaucet.com. That's not it. So not DevNet. Let's send it here. So consent. Get more tokens. Consent. Let's see. I have one issue. I don't care. If I refresh, that didn't work. It says token sent, but nothing was sent. Should appear shortly. I'm gonna create my own token if that doesn't work. Yeah, let's create our own. Let's just do token, create token with 6 decimals because that's what USDC has. And then that's my token, D9 token. Create an account for this. Mint this token, I don't know, 1,000. And then transfer 100 tokens to this address. Funding, fund the recipient. And it's also broke, so here you go. Cool. Now we just need to tell this whole thing that the USDC definite mint that we want to use is a different one. How do I do that? By searching for this. Utils. Here. Definite USDC mint is this address. No, it's this address. Save. And token keg is the correct token program. That should work. Yeah, that should be fine. I'm not sure if I need to restart this. No, I don't. Look, I have $100 now. It's my own dollars, but it's dollars. Okay, and that's all I have on this wallet. Let's ask you something. Wallet not connected or signer not available. I thought I had a wallet connected. Oh no, is my wallet gone now again? Locally in my browser. Maybe that's a bad idea. Maybe I do want to use Solve there. There you go. Let's use this. Transfer 100 to this wallet. And now, wallet not connected. What the hell? Oh, then I need, wait. I have to have a wallet connected and have a local wallet and then transfer to this wallet? Okay, I see. Maybe that one wallet represents the server's wallet and one wallet represents the client's wallet. Maybe that's it. So now I need something on the client. Okay, I'll also transfer some there. You can all have some pseudosol. Here, have some. There you go. So the client wallet should now have 100 USDC. The server wallet also, and a bunch more. And that has some sol. And if I now post something to the AI, transaction failed. But it was already, we're already getting further. Transaction failed when it was simulated in order to estimate compute unit consumption. Inspect the cause property of this error to learn more. Okay, so the signer in this case is our local key that we have in the browser. So far so good. But something is still wrong with our transaction, that the simulation fails. And then I can't get the compute units because the simulation fails. That's the issue. But I don't see where that transaction is being built. So this is difficult to debug for me. Somewhere in here. This huge. If we catch an error, we throw an error. Oh, great. So it could also come from here. Could come from in here. It does come from here though. Okay, I don't think I can get this to work. Let's look at this. So there seems to be an example in here as well with the Solana TS. Maybe I should look at that. Because I just spent an hour looking at some other thing from some other guy who I don't even know. Maybe that even doesn't work. Doesn't matter. Let's look at this. Let's look at the examples in here. TypeScript, clients, fetch. No, where was it? TypeScript, clients, fetch. Is there Solana TS? Client, fetch. There's no Solana TS. You can use the example server, but I don't find that what he added here. Examples, TypeScript, clients, fetch, multi-network signer. Is that the thing we need? It does the same thing. It does a rep fetch with payment and then the sign up. Okay, you know what? I think we're gonna just end the video here because this is not getting any better. We have established that it's difficult. Like I can't get it to work easily with the examples. We will need to look at that in more depth. Okay. I've come to the conclusion that 4 hours is not enough to figure out how x402 works, and that's okay. We understand what it is. We understand why it's useful. So I understand that I'm not giving up on that, but I'll need to do a more technical deep dive and really understand what's happening there, and then maybe just build my own system, build my own application from the ground up. That's what we gotta do in the next video that you can maybe find here. Thank you for watching this intro to the x402 standard, and I will see you in the deep dive. But it would still be nice to see it in action. I still want to see it in action. Okay, let's try it. So, let's say I had a Phantom wallet. I need an Ethereum account. Okay, fine. Let's say I had a Phantom wallet with an Ethereum account. You're not in testnet mode. Let's say I had an Ethereum wallet in testnet mode. I don't have enough balance. There was something with I can get some here. Right. This hasn't worked so far. Oh, but this has worked. Look, this for this wallet it seemed to work. Great. For Solana it didn't work. Wait, does it also work for Solana? Solana definite. Nope, for Solana it doesn't seem to work. But it does work for Base. Okay, good enough. So, if I had a Base wallet on testnet with some funds, there we go. No balance changes found. What's the message? Domain, contract address. I just confirm. Protected content. Oh ho! Yeah, love it. Nice. So that payment seems to have worked. Can I see that here? I have no activity. Okay, hold on. But did something happen? Yes, something happened. Look, my USDC balance went down. So I did pay for that. And that's the whole idea of this thing, this standard. You pay a little bit to be able to access some content or some API. And it went super smoothly. I mean, did you see how if I want to go there, I need to pay again? It just prompts me that I gotta sign, and boom, I can access that content. And in the background, it actually fulfills the transaction. Now, I don't know how Base works. It seems that message signing is enough that it can deduct some of my USDC. If we, let's see, the contract, let's see on Basescan, is that the entire contract? Oh, difficult to say what was what's my address again? 0x9 to 24. Let's just check this. There, this was such a transaction. Looks like we've got an ERC20 token transferred from here to here for that many USDC. So that's 1 cent being transferred. Wait, let's do it again. I will pay now. I will sign. I'll stop this from playing and I will refresh here. Maybe this was mine now. Yeah, this is mine now. Here we see this is the address that's signed. I'm not sure where that comes from, but they also pay the transaction fees. I literally just from my account pay the 0.01 USDC to that address. Cool. So that's how that works on Base testnet. I would love to figure out how that's done for Solana as well. But that, my dear, is a topic for a future video. Because I have tried and I have failed and I need a break for today. But we do understand what that standard is. We know what it's good for. Now we just need to figure out how we can use it on Solana. So I will definitely have to do a deep dive on this and probably build our own application with all the parts, the client, the server, the facilitator, so that we really understand how this process goes, how it works for Solana. But it's good to just have this intro. I'm gonna make shorter videos, he says after recording for 2.5 hours. And then you will find the deep dive right here. Once it's out, there's another video. You can like if you enjoyed. Give me a like if you want to see that deep dive. I mean, it's coming. It will be, I will do that. Because I'm interested in it as well. I mean, it's so cool. I just haven't yet figured it out. Because there's not much documentation on it. And I'll just have to actually get some dev work done and build stuff myself until we have it working. So I'll see you in the next video. Until then, enjoy. Yeah, I'm not giving up on that. See you in the next one.